In the last video, I have explained the derivation of settling velocity of a discrete particles. In this video, I am going to explain the design criteria of a sedimentation tank. Some of the design criteria of a sedimentation tank are detention period, overflow rate and surface loading, basin dimension, inlet and outlet arrangement, and sludge removal device. All these are the design criteria of the or design elements of a sedimentation tank. Before designing, you must go through these elements. Before designing the sedimentation tank, you must go through these design elements or design criteria. First design criteria is detention period. The detention time is the theoretical time taken by a particle of water. Detention time is a time taken by a particle of water to pass between entry and exit of a settling tank. Entry and exit of a settling tank is nothing but a detention period. Whatever the particle having the time taken for entry and exit of the settling tank is nothing but detention period. If V is the volume of a basin and Q is the discharge rate and dt is the detention time, dt is equal to V by Q, where V is the volume of tank and Q is the discharge. And here V, volume of the tank, can be replaced by length into breadth into depth. The value of the detention period depends upon the type of a suspended impurities in the water and may vary from 4 to 8 hours. The detention time period in general, we take it as 4 to 8 hours. And the L is the length of the tank, B is the breadth of the tank, and D is the depth of the tank. Depth of the settling tank is to be considered usually 3.5 to 6 meter. In general, we'll take the depth of the settling tank as 4 meter. If any coagulants are added to the water treatment, the detention period will be 3 to 4 hours. In the same way, the next design element is overflow rate. The quantity of water passing per hour per unit horizontal area. The quantity or the amount of water passing per hour per unit horizontal area is known as surface overflow rate. SOR is equal to Q divided by L into B, where Q is the discharge rate and L is the length of the tank and B is the breadth of the tank. Next design element is basin. Before that, first design element is the detention time, overflow rate, and the next one is basin dimension. The basin dimension is nothing but the surface area of a basin is determined on the basis of the overflow rate and surface loading rate. The surface area is equal to volume of water in liters per hour divided by surface loading rate, liters per hour per meter square. And the length to width ratio of a rectangular tank, in general, we should prefer 3:1 to 5:1. This is the length to width ratio of a rectangular sedimentation tank, that is 3:1 to 5:1. And the depth, in general, depth of a basin is kept between 2.5 to 5 meter with a preferred value of 3 meter, inclusive of allowance for a sludge storage, and the velocity is 0.2 to 0.4 meter per minute. Next concept is coagulant aided sedimentation. Coagulant aided sedimentation is nothing but, as you all know about the sedimentation, right? Sedimentation is nothing but the removal of the settleable suspended particles through gravitation, right? Yes, if you add the coagulants, even after the gravitational force is applied, if it is still any contains the suspended particles, that can be removed by adding a coagulant. That is nothing but a coagulant aided sedimentation tank. Yes, if you add the coagulants into a water, yes, still if it contains any suspended particles, that get mixed with the coagulants and form a white gelatinous PPT. or it can be called it as a flock, flock, flock. When you add a coagulant into a water, the suspended particles get mixed with a coagulant and it form a flock. And due to the gravitational force, again it will be settled at the bottom of a tank. Such process is called as coagulant aided sedimentation tank. Yes, some of the coagulants are aluminium sulfate. It can also be called it as alum. Its chemical formula for the alum is Al2SO4 thrice 18H2O. Al2SO4 thrice 18H2O. Next, chlorinated copper as ferrous sulfate, magnesium carbonate and sodium aluminate. These are all the types of coagulant. Aluminium sulfate, chlorinated copper as ferrous sulfate, magnesium carbonate and sodium aluminate. These are all the types of coagulant or common coagulants used for the sedimentation. In general, we used alum as a coagulant. Here alum can also be called it as aluminium sulfate. It is proved to be an effective coagulant. It is a very effective coagulant when compared to the other coagulant. It reduces the taste, odor, and also it reduces a turbidity, and it is very cheap when compared to other coagulant. Now, in general, it can be the chemical formula of the aluminium sulfate or alum is Al2SO4 thrice and 18H2O. Plus, when this alum is added to water, the water which contains the hardness, right, that is calcium bicarbonate, get mixed with the alum, it will form Al2OH thrice plus CaSO4 calcium sulfate and 18H2O, and the carbon dioxide is released.